Now, relation between degree Celsius, degree Fahrenheit, and Kelvin. We know see the scale upper fixed point 100 degrees Celsius, lower fixed point at 0 degrees Celsius. This is Celsius scale. Here is the temperature T. Now, this is Fahrenheit scale. This is 0 degrees Celsius. Fahrenheit means 32 degree Fahrenheit. That's the melting point of ice, and 212 degree Fahrenheit is the boiling point of water. And next is Kelvin. In Kelvin, 273.15 Kelvin is melting point of ice or lower fixed point, and 373.15 Kelvin is upper fixed point, and this is the boiling point of water. Now, relation between these three scales is the temperature Tf. This is the temperature Tk. Now, Tc minus lower fixed point, that is 0, divided by upper fixed point 100 minus lower fixed point is equals to this. Tf minus lower fixed point is 32 divided by upper fixed point is 212 minus lower fixed point is 32 equals to, in Kelvin, T minus 273.15. This is the lower fixed point divided by upper fixed point 373.15 minus lower fixed point. Or we can write this as T Tk. Tc divided by 100 is equals to Tf minus 32 divided by 180 is equals to Tk minus 273.15 divided by 100. Or we can write Tc divided by 5 is equals to Tf minus 32 divided by 9 minus Tk equals to, Tk minus 273.15 divided by 5. This is the relation between degree Celsius, Fahrenheit, and Kelvin. This is very important. Very important. Now, what is now we study specific heat. What is specific heat? What is specific heat? We want to define this down. Specific heat. Specific heat of a substance. Specific heat of a substance is equal to the heat gain or release by that substance to raise or fall its temperature by 1 degree Celsius for a unit mass of substance. This is the specific heat. Specific heat of a substance. Define specific heat of a substance is equal to the heat gain or released by that substance to raise or fall its temperature by 1 degree Celsius for a unit mass of substance. So important, for a unit mass of substance. This is specific heat. Specific heat of a substance is equal to heat gain or released by that substance to raise or fall its temperature by 1 degree Celsius for a unit mass of substance. This is specific heat. It means when a body is heated, it gains heat. On the other hand, it is lost when the body is cold. The gain or loss of heat is directly proportional to if we heat a body is heated. If a body is heated, if a body is heated, that means its temperature is rises or it gains heat. It gains heat. And another one is if a body is cold, if it is cool, that means heat is released, heat is lost. In this case, lost. That means gain or loss of heat, we can say gain or loss of heat is directly proportional to gain. This is gain or loss of heat. Gain or loss of heat. Q is directly proportional to mass of the body and raise or fall of temperature of the body. First is directly proportional to the mass of the body, and second is this Q is directly proportional to the rise or fall of temperature of the body. This delta T is rise or fall of the rise or fall of temperature of the body. From these two equations we can write Q is directly proportional to M delta T. M delta T. If we want to remove this proportionality sign, then we can also write this term as Q is equals to ms delta T. This is very important. Here this constant, this proportionality constant S. This is a constant and it is known as the specific heat of the body. Specific heat of the body. Specific heat of the body. That means if you want to define S, that means S is equals to, from this formula, S is equals to Q divided by M delta T. This is the formula for specific heat of a body. This is also very important. Now if you want to define unit of specific heat, SI unit of this is SI unit of specific heat. SI unit of specific heat is joule per mass having unit kg and temperature having unit Celsius. SI unit of temperature is Kelvin. Joule per kg Kelvin, and Celsius unit is you having Celsius unit of arc and mass having gram. That is arc per gram degree Celsius. This is the Celsius unit and this is the SI unit of specific heat. Joule per kg Kelvin. Okay, now star mark specific heat of water. This is very important and we have to know about this. Specific heat of water. S is equals to 4200 joule per kg degree Celsius in joule per kg degree Celsius. If we want this term in calorie, in terms of calorie, then S is equals to 1000 calorie per kg degree Celsius. This value in term of calorie per kg. And if we want this term in kilocalorie, that means S is equals to 1 kilocalorie per kg degree Celsius. This term, this value, specific heat of water, this value 4200 is in unit of joule per kg. This is in calorie per kg and this is in kilocalorie per kg. And if we want this term in Celsius unit, that means S is equals to 1. That means S is equals to 1 calorie per gram degree Celsius. 1 calorie per gram degree Celsius. If we want specific heat of steam, specific heat of steam specific heat of steam is equals to half of specific heat of water is equals to specific heat of ice. Half of specific heat of water is half of specific heat of water, and which is equals to specific heat of ice. Specific heat of ice. This is all about specific heat. We know what is specific heat. Here, specific heat of a substance is equal to heat gain or released by that substance to raise or cool its temperature by 1 degree Celsius. For rising 1 degree Celsius, how much heat is gained or released by that substance? Heat gain, that is known as specific heat. This is also important for a unit mass of a substance. For a unit mass of substance, you know this is a specific heat. X is the formula for specific heat is heat gain or loss of heat is directly proportional to the mass delta T, and this is Q is equals to ms delta T. SI unit of specific heat is joule per kc Kelvin, and if you want the value specific heat of water is, and specific heat of steam is equals to half of specific heat of water, which is equals to specific heat of ice. This is about specific heat. If we want to know heat capacity, another term is heat capacity. Heat capacity. Heat capacity. Heat capacity of a body is defined as the amount of heat required to raise the temperature of the body by 1 degree. By 1 degree. What is the difference between specific heat and heat capacity? In specific heat, we consider a unit mass of substance, and heat capacity we consider a body. Heat capacity of a body. Heat capacity of a body is defined as the amount of heat required to raise the temperature of that body by 1 degree. 1 degree Celsius or 1 degree Kelvin. This is heat capacity. Heat capacity is equals to N into S, where M is the mass of the body and S is the specific heat of the body. Okay, M is the mass of the body, specific heat of this body. Now, unit of heat capacity. Unit of heat capacity, SI unit is joule per Kelvin. It's a unit of this. SI unit. This is joule per Kelvin. This is the SI unit. And in practical system we use calorie degree Celsius. Now, an important point about specific heat. We know S is equals to Q divided by M delta T. If the substance undergoes a change in phase, that means no temperature rise or fall. That means delta T is equals to 0. What phase change? That means because if ice melt in liquid, then its phase changes from ice to liquid. That time its temperature change is not occur, no temperature change. That means delta T is equals to 0. If delta T, this term is equals to 0, that means specific heat is equals to infinite. Specific heat is equals to infinite. Thus the specific heat of a substance when it melts or boils at constant temperature is infinite. Thus the specific heat measures the specific heat of a substance when it melts or boils. When it melts or boils at constant temperature. At constant temperature is infinite. Infinite. And if second one is, we know F is equals to Q divided by M delta T. If the temperature of the substance changes, temperature changes without transfer of heat. Temperature changes without transfer of heat. Without transfer of heat. That means in this case, heat is constant. Heat is constant. In this case, heat is constant. That means delta Q is equals to 0. This Q means here change delta Q. But heat is supplied to the load. That means this Q is equals to 0. And if this Q is equals to, that means specific heat of this body is equals to 0. That means this specific heat of a body is 0 when heat is constant and temperature is changed. This is all about specific heat and heat capacity. This is study.